All right. Okay, today in this lesson we're going to be talking about inverse versus direct variation. So our objective is going to be able to tell the difference, to then write both direct and inverse variation equations and then use them to solve for missing pieces. Okay, so first we need to talk about direct variation. Direct variation is really a way for both x and y. Variation in general is a way for x to relate, for y to relate to x. So then therefore, for also a way for x to relate to y. But again, x is predominantly our dependent variable. Independent. I'm backwards. X is predominantly our independent variable. Independent is our independent variable. It's what we put in. It's our input. And y is our dependent because it depends on what you put in for x. Okay? Direct variation is written in the form of y equals some constant, a or k, depending on what you're going to use, some constants k times x. Your text tends to use an a here instead. It doesn't really matter. Basically, some number times x. Okay? For example, y equals 6x. Y equals 1/3 x. Y equals negative 2x. Okay, so if you can get it written in this form of y equals something, some constant, times x, then it is direct variation. Okay, meaning you multiply x by the same constant all the time to get to y. And we refer to this k or a, depending on what variable you use, we refer to that number as the constant of variation. We call it the constant of variation. Okay, so basically it's you take x times the same number all the time to get to y. Okay, so we multiply x times something and get to y. Okay, so so that k or the a, it could be the k or the a, it's just a different, depending on the type of textbook. Some textbooks use k, some textbooks use a. Really, it's just some number times x then gives you your y. Okay, so what does the graph of a direct variation look like? Well, let's go ahead and let's just do a simple y equals, let's do 2x. Okay, so to sketch this, I'm just going to create a table of values, and I'm going to put some numbers in. Well, when I put in a 1 for x, that'd be 2 times 1, that gives me 2. When I put in a 2, that would be 2 times 2, which is 4. When I put in a 3, that would be 2 times 3, which is 6. Okay, let's put in a half. That'd be 2 times a half, which is 1. Let's put in a negative. Let's put in negative 2. 2 times negative 2 is negative 4. So this looks like I'll have the point 1, 2, 2, 4, 3, 4, 5, 6. It's going to be up there. 1/2 is 1. Negative 2 is negative 4. Okay. So it looks like, oops, sorry for the bounce. Okay, it looks like we're going to have this actually perfectly straight line. And knowing what we know about linear functions, okay, this is actually, if you look at it, it's actually a y equals mx plus b, but my b is always 0. Okay, so what does the graph of direct variation look like? Well, it looks like a line. And what point must it go through? Well, if you notice, if my b, there's never any plus b on the end. In a direct variation, there's no plus b, which tells me that my b is 0, which tells me that its y-intercept is 0. Okay, so it must go through that origin where x and y are both 0. Okay. All right, so if we solve this equation, y equals kx for k. Okay, so we would divide both sides by x, because we want to get k by itself. So k equals y over x. So to get my constant, what this tells me is my constant of variation is equal to y over x. So my constant of variation is equal to y over x. So if I take my y and divide it by my x, and I get the same thing every time, that same number, that tells me for sure it is direct variation. So here, given this table of values, if I take my y and divide it by my x, so if I take, this would be negative 15 divided by negative 3, that gives me 5. Now if I take the negative 10 divided by the 2, that's also 5. The negative 5 divided by the negative 1, that's also 5. So if you've noticed here, whenever I divide them, I get 5, except for 0 divided by 0. That's undefined. But all the rest of them, 5 divided by 1, 10 divided by 2, 15 divided by 3. So this tells me for sure it is direct variation. Not only is it direct variation, but it has a constant. My k or my a is 5. So I can write my equation, y equals 5x. So this is the equation for this direct variation. Okay. All right. Two things don't always vary directly. Sometimes they vary inversely. Really, it's the same process, but instead of taking my constant times my x, we take our constant and divide it by x. Y equals k over x. Or, again, it could be written as a over x. Again, my k and my a are what we call that constant of variation. Okay, some examples. Y equals 5 over x. Okay. Y equals negative 3 over x. Okay. All of these, oh, sorry, you might not have been able to see that. These are inverse variations. So let's go ahead and let's figure out what does the graph of inverse variation look like. Well, let's do a y equals, let's stick with the 2 over x. So let's go ahead and let's come up with an xy table and let's sketch it. Let's see what this is going to look like. Well, let's see, when I put in a 1, 2 divided by 1 is 2. When I put in a 2, 2 divided by 2 is 1. When I put in a 3, 2 divided by 3, well, that's just 2/3. Put in a 4. 2 divided by 4 is 1/2. Okay, let's put in a 0. 2 divided by 0, oh wait, that's undefined. You're not able to divide by 0. Let's put in a half. 2 divided by 1/2. So 2 divided by 1/2, that's the same as 2 times 2 over 1, so that'd be 4. Okay, so let's go ahead and let's graph this. We have the point 1, 2, 2, 1. 3 would be 2/3, maybe right about there. 4 would be a half. 0 is undefined. 1/2 would be 4. 1, 2, 3, 4. Okay, what about some negatives? We didn't put any negatives into this. Let's put a negative 1. 2 divided by negative 1 is negative 2. Okay, let's put in some more negatives into that guy. So here, more xy table. Okay, let's put in a negative 2. 2 divided by negative 2 is negative 1. So negative 2, negative 1. Let's put in a negative 4. 2 divided by negative 4 is negative 1/2. Negative 1, 2, 3, 4, negative 1/2. Okay, so actually it looks like we're going to kind of get something that looks like this. And we can use Desmos or our graphing calculator to verify. Sorry, y equals 2 divided by x. Yep. So it gives us this little curve-like thing where I have these two curves in quadrant 1 and in quadrant 3. Okay. So what does the graph of this inverse variation look like? Well, we can't really describe it as well as the last one. It's basically these two curve-looking things. What point does it, that should be an it, and that is, what point does it avoid? Well, if you notice here in my origin, my graph basically goes around and doesn't go anywhere near the origin. So it avoids the origin. Unlike our direct variation that went through the origin, our inverse avoids it at all costs. Does it ever cross the x or y axis? Well, if we look here, it keeps getting closer and closer and closer to 0, but never actually crossing. So no, it doesn't. And if you notice here, it never actually crosses the y axis either. Those are what we call asymptotes. There are asymptotes at the x and y axis. Just in general on how this graph looks, because I can't actually put a 0 in it. I get a 0 undefined right here. And there's no way I can actually ever equal 0. There is no x I can put in here where I can get a 0 out. Okay. And so if we do the same thing we did before and we solve for k, multiply both sides by x, k then equals x times y. So in an inverse variation, if you multiply the x times the y and get the same thing every time, then it's an inverse variation. Okay. So if I multiply x times y, so negative 3 times negative 4 is 12. Now negative 2 times negative 6 is 12. Negative 1 times negative 12 is 12. And then again at 0 here, I can't actually put a 0 in, but 1 times 12 is 12. Okay, so I can tell here that this is inverse variation because when I multiply the x's and the y's, I get that same constant. So not only do I know it's inverse variation, but I know the constant of variation would be that 12. So my equation would be y equals 12 divided by x. And I can try it. When I take the 12 and divide it by negative 3, yep, I get negative 4. When I take 12 and divide it by negative 2, I get negative 6. So when I divide by each of these pieces, okay, I get that y value. So there is the equation for my inverse variation. Let's go ahead and let's answer some questions based on inverse and direct variation. So write the equation of a direct variation that has a constant of variation equal to 3. Well, it's direct variation, so I automatically know it's going to be y equals kx. And not only do I know it's going to be y equal to kx, they tell me the k is 3. So all I need to do is plug it in. Y equals 3x. There's my equation. Okay. Write the equation of an inverse variation. So inverse variation, I automatically know it's going to be k divided by x. That has a constant of variation equal to 9. So I know my k is 9, so it would be y equals 9 over x. Okay. Pretty straightforward once I know it's direct or inverse. Okay. All right, now let's try some problems where I need to find the constant of variation. Find the constant of a direct variation. So it's direct variation. So I know it's going to be y equals kx. I'm trying to find the constant. I'm trying to find k when x is 6 and y is negative 30. Well, I can just plug it in. X is 6, y is negative 30. So I have negative 30 equals k times 6. Divide both sides by the 6. My k then is a negative 5. Or I can remember that in direct variation, from this previous problem over here, in direct variation, my k is equal to y divided by x. Okay, so my k is equal to y divided by x. So I take my y negative 30 divided by the 6, and again you still get that negative 5. So my constant of variation is negative 5. Okay, I like to remember the least amount of things possible is needed, so I just remember this is direct variation, and inverse, or if I'm trying to find the constant for inverse variation, y equals k over x, and then I just plug in and solve. I don't like to remember this extra stuff, just it's one extra step. Okay. So find the constant of an inverse variation when x is 12 and y is 5. Well, again, if x is 12, so let's replace x with 12. We're trying to find k, and y is 5, so I have to multiply both sides by 12. So then my k would be equal to 12 times 5, which is 60. So my k is 60. Okay, So now let's solve for x or y when the constant is given. So we know y and x vary directly, so I know y equals kx. That gives me that information here. If the constant of variation is -4, so I know my k here is -4, so I'd have y equals -4x. Then what is the value of y when x is -6? Well, now I just plug in when x is -6. Y then would be 24, because -4 times -6, y is 24. All right, y and x vary inversely, so I know y is equal to k over x. If the constant of variation is 2, so k is 2, so y equals 2 over x. Then what is the value of x when y is -6? Well, when y is -6, what's x? So now to solve this, I have to multiply both sides by x. So -6 times x equals 2. Divide both sides by the -6 now. X equals -1/3. Okay. Now, how do you solve for x and y when the constant is not given? Suppose y varies directly as x. So varies directly. Y equals kx. If y equals 3 when x equals 15, so y is 3 when x is 15. Well, this will help me find my k. So if I divide both sides by the 15, that means my k is 3 over 15, which is what, 1/5? So I know my k is 1/5. So now I can rewrite my equation into 1/5 x. We want to find x when y is 5. So now that we found our k, so first things first, I had to find my k. Once I know my k, I can rewrite my direct variation with my k in it. And then now I want to find x when y is 5. So when y is 5, what's x? Well, I have to multiply both sides by the 5. That cancels. X would be 25. So you need to find, when the constant is not given, you need to find that constant first and then go from there. Okay. Suppose y varies inversely as x. So y varies inversely as x. If y equals 5 when x equals 8, so I'll need to use that to find k. Y equals 5 when x equals 8, so multiply both sides by the 8. So k is 40. So my new equation is 40 divided by x. We want to find y when x is 10. So y would be 4. Okay. All right, so now the most tricky problem we'll have is solve for the variable when there is both direct and inverse variations in the same problem. So now we need to do both direct and inverse in the same problem. A varies directly as B. So when that tells me that A varies directly as B, A varies directly, there's some constant times B. So there's direct and inversely as C. Well, inversely tells me then it's going to be over C, right? We multiply. For direct variation, you multiply times a constant. For inverse variation, you divide, okay? So here we're directly as B, but inversely as C. Okay. So again, we still have just one constant. We still have one constant of variation, but that constant of variation is times B for direct and divided by C for inverse. So here directly, I know I'm going to multiply by K, and inversely, I know I'm going to have to have K divided by that. Okay. So so I have this relationship. I don't know K. K is still a mystery. But if A equals 48, when B equals 3 and C is 2, so I don't know K, but B equals 3 and C is 2. We need to find A when B is 5 and C is 8. So first steps first, find K. So I'd have to multiply both sides by 2. 2 times 48, 96 equals K times 3. Now divide both sides by the 3. So K is 96. I don't know that one. Divided by 3 is 32. So I know my k is now 32. So I know my equation is 32b divided by c. So now they want us to find a when b is 5 and c is 8. So I want to find a when b is 5 and c is 8. So now I just need to take 32 times 5, see what I get. That's 160. Divide that by 8, we get 20. A is 20. Okay, so now go ahead and do some practice. Good luck.